So now we will talk about modifications to the helium Boyle's law porosimeter to measure pore volume, and then you will see we will also measure the volume of the adsorbed gas using this modified helium Boyle's law porosimeter. So if you remember what I showed in the previous slide, there were 3 steps. You will first calculate the porosity using the standard helium Boyle's law porosimeter. But this time around, you will be doing it on crushed sample. Why? So that it takes less time for the gas to be in equilibrium between the sample cell and the small pore spaces within the crushed sample. It also gives you larger surface area to volume ratio. So it's easier for the gas to go into the smaller pores than if you had an intact core, and then it takes forever for the gas to go into all of the pores and to be in equilibrium with the pressure in the sample cell. So again, this is stage 2. Stage 1, you calculate porosity as usual, which involved calculating Vs using helium, right? And then from Vs you get porosity. But here you want to get the volume that has been adsorbed into the pore walls of these crushed sample. So we use the same ideal gas equation. The total number of moles will be all of the moles in reference cell plus, we already had this from helium porosimeter, right? Now we are saying, in addition to the fact that the gas can be stored in the space outside of the crushed sample plus in the space within the pores, so the pore volume within the sample, there is also the potential to store gas in the sorbed state on the pore walls of the internal surfaces of this crushed sample. And that volume that will be adsorbed is VADS, shown here. So all we've done is to add the volume that can be adsorbed to this volume difference, which is the volume in the rest of the sample cell plus the volume available for free gas storage inside the pore space, and then we divide by RT. So this is the total number of moles at initial conditions. Then we open the valve, right, and let the gas flow into it, and then we wait. Now it's going to take much longer time to reach equilibrium. And at equilibrium, it's exactly the same kind of equation from before, right? Only thing is we've added adsorbed volume. I should point out that although we are calling this thing modified helium Boyle's law porosimeter, we actually will not use helium to calculate this V adsorption. Why? Because helium is a non-adsorbing gas, right? We talked about that. So you will need to use an adsorbing gas like methane, ethane, and these common gases, hydrocarbon gases that we'll find in petroleum reservoirs. So what do we do next? You have 2 expressions for the total number of moles, and you know that the total number of moles will be conserved, right? So equate this right hand side to this, and then you can cancel, you can multiply both sides by RT, right? And that goes away, and you have this form of the equation, right? And then, like we did before, now you make V adsorption the subject of the equation. How do you get Vs? Exactly how we got it using helium Boyle's law porosimeter, right? So this already came from helium Boyle's law porosimeter using helium. And then, so this is known. Of course, these are known like before. And then you just need to make volume of adsorbed gas subject of the equation. Of course, it also shows up right here. So take them to one side of the equation and then make it the subject of equation, and I will leave that as an